My God! The car!
Traffic police. Goodness me. You were 20 miles over the speed limit and driving on the friggin' footpath.
Wait, are you even... God, you weren't drunk driving, were you?
Fine. Now, just step out of it. Wait your turn. Now, just breathe. I knew it! Drunk!
Prove it!
Fine. You're hallucinating because you are drunk.
Oh, okay then.
Alcohol does not undergo a reaction when in the bloodstream. When blood reaches the air sacs, alcohol is able to diffuse through the membrane as a vapor. The quantity of ethanol in breath will be fixed because the rate of evaporation of ethanol from blood will equal the rate of condensation, and this will establish an equilibrium. When a sample of breath is taken, the ratio of blood to breath alcohol is constant, so the actual blood alcohol level can be measured. This is possible because of Henry's law, in which the concentration of gas in a solvent is proportional to its partial pressure. Even though water and alcohol are miscible liquids, this provides a good approximation of the extent to which the solution evaporates, condenses, and the composition of the vapor. Remember that ethanol is a volatile liquid which can evaporate very easily on its own. The legal limit in Singapore is 35 micrograms of alcohol per 100 milliliters of breath, or more than 80 milligrams of alcohol per 100 milliliters of blood. One type of breathalyzer uses potassium dichromate solution to oxidize ethanol to ethanoic acid. The quantity of dichromate needed is determined by the mole ratio of ethanol to dichromate. At the endpoint, dichromate changes color from orange to green when the dichromate ions are oxidized to trivalent chromium. To simplify things, we assume the breathalyzer has a threshold amount of dichromate, and assume that no ethanol is produced as final products. When the reaction has been completed, the color of the solution will correspond to the concentration of breath alcohol. This can be determined by a colorimeter connected to a microprocessor, which allows policemen to determine if the driver is breaking the law. This solution contains potassium dichromate, dilute sulfuric acid, and silver nitrate. This represents the suspect's breath, which contains ethanol. I shall now conduct an experiment to determine the color change when a suspect blows into the breathalyzer. The solution has now turned green, indicating that chromium ions have been reduced. Another type of breathalyzer uses electrical current to determine the breath alcohol concentration. As a simplified representation, the breath is collected over a solution containing aqueous hydrogen ions and a platinum electrode, which will act as the anode. The wire connects it to another platinum electrode, which contains oxygen from air, and a solution containing hydrogen ions, which acts as a cathode, in addition to a microprocessor to measure the potential difference across the two electrodes. There will be potential difference between the two electrodes when ethanol is oxidized to ethanoic acid, while oxygen will be reduced to water, creating current. This is possible because of the relative strength of the reducing agent, which is ethanol, and of the oxidizing agent, which is dichromate, as measured by standard electrode potentials. The reaction will be feasible as long as the cell potential is positive. The quantity and concentration of alcohol can be measured by the microprocessor after the potential difference or cell potential has been determined.
So, Mr. Drunk Driver, do you understand it?
Ah well, it's only the third one this week. Oh, it's lunchtime.